We also need to go back and review some special types of functions that we'll be looking at this semester. One function is the absolute value function. Remember, for the absolute value function, the absolute value of any x is x when x is greater than or equal to 0, or negative x when x is less than 0. Remember, the technical definition for absolute value is distance from 0 on the number line. So if we have a value 5, the absolute value of 5 is 5 because 5 is 5 units from 0 on the number line. If we have negative 3, the absolute value of negative 3 is 3, since negative 3 is 3 units from 0 on the number line. The graph of a basic absolute value function, y equals absolute value of x, always makes a V-shaped graph. It has a domain from negative infinity to infinity and a range from 0 to infinity. The absolute value function is an example of a piecewise graph. Another piecewise graph that we saw earlier when we were talking about increasing and decreasing functions is given here. This graph is actually defined in 3 different pieces. All the x's less than 0 go into the function f of x equals negative x. All of the x's between 0 and 1 inclusive go into the function f of x equals x squared. All of the x's greater than 1 go into the function f of x equals 1. So the graph appears to be parts of 3 functions joined together. Remember, linear functions are functions of the form f of x equals mx plus b, where m and b are constants. Linear functions are called linear functions because their graphs form straight lines. Here's some examples of linear functions. On the left you can see that the m is varied. We have y equals 1/2 x, y equals x, y equals 2x, y equals negative 3x, and y equals negative x. The m, remember, is the slope of the line. When slopes are positive, you have increasing lines, as you see in blue, and when the slopes are negative, you have decreasing lines, as you see in yellow. Notice on the right we have y equals 3/2, and m is equal to 0 there. Since the slope is 0, we have a constant function, or a horizontal line. We also deal with a lot of power functions in calculus. A power function is a function f of x equals x to the a power, where a is a constant. We've looked at some of these already in our last recording. Y equals x squared, y equals x cubed. Or we could have y equals x to the 4th, y equals x to the 5th. Our a, when we do x to the a power, could actually be any number. It does not necessarily have to be a positive integer, as you see here. If it's a negative integer, like negative 1 or negative 2, we have graphs such as you see in figure 115. These are graphs of rational functions. Notice that each one of these have a domain where x cannot be equal to 0. If x is a fraction, like we see here, if a is a fraction like we see here, if a is 1/2, x to the 1/2 power is the same as the square root of x. Or if a is 1/3, x to the 1/3 is the same as the cube root of x. And so we see some graphs here of power functions where a is a rational number. Remember that a function p is a polynomial when it's given in this form. When we are dealing with polynomials, some things you want to remember are that your exponents are going to be positive, integers, or 0 where you have your constant term. A rational function is basically just a quotient of polynomials. It's a polynomial divided by another polynomial, as you see in these examples. Some other graphs you need to remind yourself of are the graphs of f of x equals sine x and f of x equals cosine x. We'll be seeing those this semester. We'll also deal with some exponential functions. Remember, with exponential functions, our base is a constant and our variable is an exponent. The graph to the left shows 2 to the x, y equals 2 to the x, y equals 3 to the x, and y equals 10 to the x. The graph on the right shows y equals 2 to the negative x, y equals 3 to the negative x, and y equals 10 to the negative x. Another type of function we'll be dealing with this semester are logarithmic functions, so you need to familiarize yourself with those. Remember, logarithmic functions have a constant base. So here we see log base 10 of x, which is our common log. We see log base 5 of x, log base 2 of x, and log base 3 of x. We may deal with other functions, but be sure to review and familiarize yourself with these functions before we begin.